is visible?
Yes, sir.
Can
Yes,
you
sir.
people see this?
Yes,
Yes,
sir.
sir. Yes. Very very good. Very good. Yes. So in the last lecture, we have seen this paged memory management, right? And our question, and we ended this particular session by suggesting a question, and that question is it really reasonable to try to run a job or a task without loading its entire address space into primary memory? Say, which means, like, if this job 2 takes 3 pages, needs 3 pages, so it is really reasonable, like if you wanted to execute this particular task onto a system, we need to load all these 3 pages. If they are loaded into the primary memory, then only I can execute this particular task. It is irrelevant if whether they are contiguous or non-contiguous, right? Because we have got a reference here, right? We have got a reference here that is called link. So means what? After this particular page where we are going to have, like, say, if you look at page 0 of job 2, it is being referenced to page number 4. So the memory block number 4, on memory block number 4 you have page number 2 on, and this is being referenced to memory block number 6, where you'll find the third page to be loaded. Okay, so it means that it is, though it is logically contiguous onto a primary memory, still with the link itself we can refer. So but the case is that for executing this page, we need all 3 pages to be loaded into the primary memory. The fair question, that is it really reasonable to try to run a job without loading its entire address space? So means without loading an entire address space of a job or a task, can we execute the can we execute or can we run a job without loading its entire address space? So the question, the reasonable question is, uh, can we execute a task without loading its address space completely? Right. So what is your opinion on this? What do you think? Can we execute a task without loading an address space completely onto a memory? Like here, if suppose only two, like say for example, now we'll have one more a little more example here, just to have you uh, got an uh, representation, like, okay. So say for example, here you have got job 4, and this particular job 4 has got this address space. So it requires 3 pages. So this is 0th page, this is 0th page, this is page number 1, this is page number 2. And in the present situation, only 2 blocks are available with us, that is 0th block is available and 5 block is available. So is it possible for me, because with this particular thing I have a page map table, right? So with respect to these 3 blocks, so this is 0th block, this is first, this is second page. I can only load these two, either of these two pages into primary memory. So is it really possible for me to execute or run this particular job number 4 uh, here? So what is your opinion? Okay, this you can, like, this you can say that, okay, your job, your page number 0 is going to be, say, for example, main. Your page number 1 is going to be, say, function this A, function B is your page number 2. So yes, so can we still execute these 3 pages here? 3 pages and 2 memory blocks are available with us. So this is the broader spectrum of the pages. Yes. Let me understand this. So there, in this case, there are only two solutions, either yes or no. So so the answer is answer to this particular question is, can we execute a job without loading its complete address space into a primary memory? The answer is yes.
No.
Execute. You can execute the address space. You can execute the job without loading its complete address space, right? So the answer to this is yes, right? So which means, if the answer is yes, which means loading a page as per its demand. So this demand word will be like as per requirement, as per requirement. So what we understand is this. We understand is this, that what prior knowledge we have, prior knowledge which we have learned into page memory management, that user address space is divided into pages. Okay, so user address space is divided into pages. This is one. Second, memory is divided into blocks, right? The interesting part is the block size is equals to the page size. Okay, so this is block size and page size. This is, again, it is pre-configured. So this is pre-configured, and who is going to decide? This is being decided by operating system. Okay, this is being decided by operating system kernel particular. Okay, so this is being decided by operating system kernel. Okay, so what is going to be the block size, what is going to be the page size? So this is what we have done. Okay, so the case is that prior knowledge which we have, that user address space is divided into pages, memory blocks are divided into, memory is divided into blocks, and just to maintain the relationship between the pages and the memory block, we have used hardwares as registers, right? And these registers are nothing but, say, PMT. This is called page map tables, and next is memory block tables. So this page map tables and memory block tables. Okay, and which tells us is that that this address space, which is actually allocated for the user on this address space, the pages are contiguous, right? Pages are contiguous onto address space, but they are logically contiguous onto primary memory, and their relationships are being maintained here in memory block table as well as page map table. Okay, so in case of memory block table, the interesting point which you need to understand is, say, this is memory block number, then this is description, okay, like which page you are going to use, or likewise then size, then its link, okay, or its reference. Okay, so means if you have more than one pages, then which page is going to come up to that as far as the execution is concerned. So this being maintained here. Okay, so the question is like, okay, if this is the case, then we are saying that can we execute a task without loading its entire address space completely into primary memory? The answer is yes. So loading the page as per the demand. So if the page is loading as per the demand, there are certain modifications that are required here. Okay, so the modifications are made into the page map table. So if I say if it is being pages are being loaded as per the demand, then the modification is in this modification. So in the page map table, so modification is priorly to the page map table. We just have only two attributes here, page number and block number. So this is what we have, page number, and it's allocated block number. So we are going to modify this into three attributed information. Okay, so this is page number, its status, right, and a block number. Okay, so this is important. Okay, but see, when the pages are loading as per the demand, so when this word comes, demand comes, which will gives us another perception that when the demand comes, then the movement of the pages are going to come. Okay, so the movement of pages are going to come means what? So say for example, the movement is, this is user address space. Okay, and this user address space, and you have a page map table, and you have memory. So this is memory. So this is, say for example, this is one page, this is two page, this is 3 and 4 page. So you have page map table. So which is nothing but it is again three attributed information. It is going to be like this. So this is page one, this is two, 3 and 4. Okay, and just take a case that we just have some of the memory blocks that are available here, some of the memory blocks. Okay, so those memory blocks available here is this one, say this one block, and say this block. Okay, just to understand this is, say this is zeroth block, this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, and 8. So what are the blocks available? Only 3 blocks we have available right now. This is 3 blocks, okay, that is 2, 5, and 8. So the block numbers, say memory block number 2, this is available, memory block number 5 is available, and memory block number 8 is available. So means what? This demand is like, say if we look at this broader perspective, that we have a page something like this. Say this is going to be my main function, this is page 0, then we have got another page, that is, say function A, then we have function B, then we have function C. So this is going to be my third, fourth page. Okay, so if suppose in this case, what if this case, so this page 1 is required, so I'll say 0th page. This is going to be my 0th page, this is going to be my first page, this is going to be my second page, this is going to be my third page. So 0th page, so I'm going to like say 0th page is required, yes. So it is being allocated at second page. Okay, second memory block. Then this requires, say for example, this requires function A, so there is a call to function A here. So if there is a call to a function A, so I can only load function A. Okay, so which means that my page number 1 is function A, page number 2 is my function B, page number 3 is this. Okay, so this is 0, 1, 2, and 3. Okay, so in the case is that, okay, this is loaded, this is required, this is on this. Okay, and as far as if you look at the memory block table, what is required is here, you'll find that this particular memory block table has a reference, right? So this is going to be like, say, 4 attributed information, and this is for the 4th attributed information. So this contains the information of all the number of blocks that are available into a system. Okay, so this is going to be like this. Okay, so this is, okay, how many? 8. So this is zeroth memory block, this is 1, this is 2, this is 3, this is 4, 5, then 6, 7, 8. Say for example, the concept is something like this. Okay. Okay, 6, 7, and 8. Okay, so say here the things are different. So here at 2, you have got, say, this is memory block number 2. You have got a memory block number 2. This is memory block number 2. You have, say, this is the task, we can say. This is being identified with some unique name. So we are going to give the name to this is, say, uh, uh, T8, say for example. So it is at memory block T8 page 0. So this is going to come. Okay, and the size is, say for example, it is 5K size, and this requires page 1 to be loaded. So in the case of the reference, this page 1 is to be loaded, but page 1 is in 5. So page 1 is in memory block number 5. So this is here on memory block number 5. So this is memory block number 5. You are loading T8 page 1, which is of 5K. Okay, T8 page 1 of 5K, and this page 1 has not any reference, right? So it does its job and move away. Okay, so means what? Here for the period of time it will come. So this is 1, yes. This is second block. You need a page number 1. So you are in requiring page number 1. So the status is required, yes. So it is being loaded at block number 5. Okay, so means what? This particular page, this page is going to come to here, does its job, and being moved out back to the user address space. Okay, where? Here, being moved back. So means what? From this, so whenever there is a demand, the page is moved. So whenever there is a demand and we are using this particular status attribute, so which means that we are loading a page as per the demand. So if there is a page is having a demand, so page is moved. So it is moved from user address to memory and back. Okay, and back. And back means what? Whenever it is done, it is being reverted back. So it is like this. Okay, done. It is reverted back. Once it is over, the status is being modified as no, and this is going to be an empty. So there is in this case, if it is reverted back, you can go for that. You'll find there is nothing here. Okay, so no reference here. Okay,